right. Good morning, everyone, and thanks for joining us on the Data and Information Technology session. My name is Colby Creedon, and I'm with Empire State Development's Division of Science, Technology and Innovation, also known as NISTAR. I'll be the moderator here for the next about 50 minutes, and we've got a pretty impressive lineup today. The panelists are going to have an exciting discussion. This session will focus on a number of different highlights in the information and technologies industry, cluster that's being developed here in New York State. We'll highlight some of the key capabilities and innovations with a focus on how companies can leverage the robust R&D ecosystem that's supported by NISTAR. Our topic for this session is meant to delve into a set of technology areas that could be called enabling technologies, information and data technologies that are really shaping the future of all other industries. For example, big data, artificial intelligence, sensors, software, and computing innovations. Advancements in these areas are set to transform business operations of all kinds, enable smart cities infrastructure, improve the delivery of healthcare, and propel newer industries like unmanned vehicles. New York State, of course, has a thriving tech community and first-rate talent pipeline that have helped propel our leadership in these areas. We'll hear from two of the NISTAR-funded centers that are especially active in this space, the Center for Emerging and Innovative Sciences at the University of Rochester and the Center for Advanced Technology at the City University of New York's Advanced Sciences Research Center. And we'll also hear from two companies that will highlight how they're advancing these critical technologies and applying them in the private. Before we kick off, I'd just like to orient you briefly on some housekeeping matters. If you have any questions, please use the Q&A function you'll find at the bottom of your screen. Everyone's mic will be muted and the chat is disabled. So please remember to use the Q&A function, and the questions will be presented and we'll get you an answer. To kick things off, I'll ask the panelists to give a little intro about themselves and their organizations, starting with Terry Moore from MCCI.
Hey, good morning. Thanks, Colby. Yeah, I'm Terry Moore. I'm the founder and CEO of MCCI Corporation, which is a system software company based in Ithaca and New York City. We actually also have some presence overseas. We've been in business for about 25 years. We're right now making a transition from being exclusively focused on working with Fortune 100 companies doing OEM system software for people like Microsoft into doing system software for Internet of Things and developing the entire systems end to end for that. I'll talk more about that probably later. It'll be hard to stop me.
Great, thanks, Terry. All right, Dan Newman from L3 Harris.
Hi, good morning, Colby. So I'm a project manager at L3 Harris, and we work on mostly remote sensing systems, and it's for space imaging, so it involves electrical engineering disciplines and software and big data management. And we've been working with CEIS for the past 7 years.
Great.
Yep, thanks.
Thanks, Dan. And over to Mark Bocko from CEIS.
Yes, I'm Mark Bocko. I'm the director of CEIS at the University of Rochester. I'm also a professor of electrical and computer engineering here. And I've been the director of CEIS for about the last 10 years. And the focus of CEIS, CEIS used to stand for Center for Electronic Imaging Systems. And so that's still our core, is really imaging and image capture, image understanding. But the world has become much more functional than that. And so we've really expanded our scope to lots of other areas as well that are related to linking the physical world and the information world. So that'll do for now.
Thanks, Mark. And Rein Ulijn from the CUNY ASRC Sensor Cat.
Thank you, Colby. Good pronunciation of my name. We just practiced that before we started. Good morning, everybody. Yeah, pleasure to be here. So I'm at the CUNY Advanced Science Research Center, which is a 5-year-old new state-of-the-art research center in Manhattan that is essentially serves the CUNY community, but also the wider local area. It's a place with 20 academic labs and 15 state-of-the-art core facilities. It's a dynamic place where people come and go and use the facilities and collaborate. And we have focus areas on nanoscience, photonics, structural biology, and environmental science. And we were lucky enough to be designated a Center of Advanced Technology last year in the area of we focus on, especially on biomedical sensors and environmental sensors.
Great. Well, thanks everyone. And I guess we'll jump right into to some questions. Here's one for the industry folks, Terry and Dan. Starting with Terry, can you tell us the basics about your company's technology and how it improves customer products?
Sure. So as I mentioned before, we are a systems software company primarily, but we work mostly with subject matter experts, whether it be in the area of USB, where we're working with the people who really understand what their products are supposed to do. For example, digital still camera or AI, specialized AI processors. The engineers or the product managers that we work with always have a clear idea of what they want their product to accomplish from a business point of view. USB is often mission critical, but not core. So they don't really compete based on their USB performance, but USB is complex. There's a lot of stuff to do with interoperability. So we take care of that. We work with the subject matter experts. We ask them questions about what they need. We educate them as needed, and then we take care of the problem, both with software. Sometimes we build special purpose hardware. We do all kinds of things. In IoT, it's the same thing, except it's a different kind of subject matter expert. In IoT right now, we're working a lot with researchers at CUNY, through CAT, at Washington University, Cornell. These are people who have a really clear idea of what it is they want to accomplish with the data. Our job is to get the data from the field to the people who want to look at the data, and so that can be accomplished in any number of ways. We tend to focus on developing stuff with LoRaWAN, which is a remote sensing technology, a radio technology. That enables us to do a lot of stuff with community-free open networking. And so another part of the initiative is that I was the founder of and am the initiator of a 501c3 in New York City called the Things Network New York. That's part of a global initiative to develop free community access wireless sensor networks for use by researchers and students and local businesses to allow for a higher degree of local control and local initiative in remote sensing projects.
Great, thanks, Terry. And how about you, Dan? Can you talk a little bit about some of the technology that you have at your company and how it improves consumer products?
Yeah, so we're basically an aerospace company and a very diversified one. We've been working in Rochester mostly on remote sensing systems, on infrared and visible camera systems, hyperspectral imagery, and we've been working with CEIS mostly for doing advanced sensor systems, and we've looked at very novel sensors, ones using terahertz imaging, which you can use for security screening and things like that, as well as advanced IR systems. And currently, we're working on advanced optical communication systems using phase arrays, which have very nice features because they're incredibly small and lightweight, and allow you to do things like, but they're going to use them on automobiles, to do self-driving cars and things like that. So, as I said, we've been working for over 7 years with graduate students at the U of R and RIT, and have hired 4 or 5 of those students to L3 Harris over those years. So it's been a very successful program.
Great. Thanks, Dan. And now I'd like to kick it over to some of the folks at the academic institutions. Mark, can you tell us about some of the expertise and facilities that that CEIS has? And I know you've worked with L3 Harris, but can you give a couple examples? Maybe talk about some specifics of what the work you've done with L3 Harris or others?
Sure. CEIS was established as one of the NISTAR Centers for Advanced Technology more than 30 years ago now. And that was back in the heyday of Eastman Kodak and Xerox and Bosch and Lomb. And things have changed a lot in Rochester over the last 30 plus years. And CEIS has changed, adapted to go along with that change. Now, the CEIS is, we historically, our core expertise has been in imaging and optics and photonics. But in the last 15 years, we've expanded to lots of other areas, including that are really related to the creating systems out of these technologies. And so we've worked with companies in wireless sensor networks, done a lot of work in integrated electronics and chip design, and even acoustics most recently in some other L3 Harris projects. So it's really, gathering information about the environment and making decisions about what you're seeing has become a very multimodal sort of and a system related enterprise. So broadly speaking, we're interested in the sensors and the devices and the systems that connect the physical and information worlds. And we're also very interested in how to present that information to humans in usable ways. It's very easy to create information that actually has negative value. We're swimming in information these days. And so creating information that has value to humans is really one of the major challenges. So we do not have centralized facilities at CEIS, but we draw on the labs and the expertise of faculty investigators at both the University of Rochester, including the U of R's Medical Center, which is a very large research enterprise, and the Rochester Institute of Technology. So we've supported investigators and joint projects with people from all of those, and even some other universities like Cornell and Alfred in the past. So some of the other capabilities that we've tapped on most recently in some of the projects we've done a lot of work in vision and visual perception, and we have the Flom Eye Institute at the Medical Center, and just related the Center for Vision Studies. We've done a lot of work in integrated circuits, and especially photonic integrated circuits. Image processing remains a large part of everything that we do. We have done some projects in virtual and augmented reality, which sort of combines all of the above. And then talking a little bit about multimodal interactions with information. We've even done work and have resident expertise in acoustics and audio and multimodal human perception and interfaces. And then building systems out of these. Wireless sensor networks is another area that we've tapped on some of the local expertise. So just a few examples of some of the companies that we've worked with. L3 Harris, of course, has been one of our most active partnerships for many years. Dan referred briefly to the development of a terahertz camera for security purposes, and it's also useful for sort of manufacturing quality control. You can see inside of cardboard boxes and plastic containers, things like that, using terahertz radiation. And that was a great example of a collaborative project between people at Harris, but also the University of Rochester and RIT. And so it involved everything from integrated circuit design and chip design, which was folks at the University of Rochester, and then infrared and millimeter wave testing, which was largely done over at RIT. So that created a very interesting outcome and a working terahertz camera. Just a couple of other companies that we've done a lot of work with. One of them is Clario Vision, which is that we've worked with at least 6 different principal investigators over the last several years. They're a company, a local startup company, which has raised quite a bit of capital, and they've licensed a portfolio of patents from the University of Rochester in vision correction. So they use ultra-fast lasers to modify the refractive properties of tissue. So instead of wearing contact lenses, they can change the refractive properties of the lens in one's eye. So that's been a very, very productive relationship. And just one more example, CareStream Medical Imaging here in Rochester. We've done work with them in the last couple of years on developing a very compact computational ultrasound imaging system that has several times the resolution of conventional ultrasound imaging systems, but more importantly, it has the ability to image through the skull, which conventional ultrasound imaging just can't do. And so this could be really impactful for, say, the rapid assessment of stroke patients, and to see that they're given the proper treatment. And so that has drawn on the strengths both on the River campus at the University of Rochester in image processing and ultrasound. And the UR Medical Center has a very active and well-established group of researchers working in ultrasound imaging and image processing. So that's a few examples. I'll stop with that.
Thanks, Mark. Lots of 30 years of experience there, lots of collaboration amongst industry and universities, and some cool technologies and innovation. How about Rein? Similar question. Can you talk a little bit about the expertise of your center, and maybe some of the partnerships that have come through over the past few years?
Sure, pleasure. So we're fairly new as a center and very new as a CAT. So we are developing. We've been in the process of developing a vision, and we've been in the process of developing and understanding what the needs are. And what we found is that the innovation center that we have here is the ASRC with 20 really amazing academic labs, and then the core facility that provides a really interesting space, especially for small companies to work in. We have instrumentation available that simply would not be available normally to small companies. So we found at the early, so I should say we started in January this year, and I guess I'd say no more. That was challenging. So we decided to focus early on COVID. It made complete sense. And we learned that there were dozens of companies in the immediate area here, small companies interested in sensors, sensing technologies, self-cleaning surfaces, lots of stuff that's relevant to, and could be pivoted and repurposed to help basically eventually get New York State back up and running. So we learned that many companies are very agile, and they can serve as a catalyst to make them to enable them to pivot and start doing new things. So that's been our main focus in the beginning. So one such company, Narova Biosense, from that came out of Memorial Sloan Kettering Center here in New York, had technology for the detection of biomarkers relevant to ovarian cancer, and they rapidly pivoted, started working on repurposing this to detect relevant biomarkers that the body that are of a body's response to COVID-19 infection. What we offer them is the ability to fast track their proof of concept devices using our nanofabrication facility. Another example is Dultec, which is that develops artificial carbohydrate receptors. They were previously proven to be highly useful, Zika detection, and this company decided to pivot towards the detection of the SARS-CoV-2 virus. We are able to then support them in getting proof of principle devices done. I should also say that while the city was in lockdown, we were able to restart some activities earlier than some other academic institutions. So we could really help some of these companies get back up and running pretty quickly. So that's one set of examples. The other set of examples I would say relates to CUNY providing an enormous population of students, 250,000 full-time, 250,000 part-time, with enormously diverse skill sets. And, we also view it as our duty to help prepare them for the workforce and work with companies to make sure that our students are well prepared and add value. So, again, it's already days for us. The start has been interesting, but we are, I think we're really filling a very important gap here in the local area in terms of providing this type of support to industry. Great,
thanks, Rein. Since you brought up preparing students for the workforce, maybe I can kick it back over to the industry folks, Terry and Dan. Starting with Terry, how do you find working with universities? Are they the students coming out of universities making sure that that you're finding students that have the right skill set that you're looking for? Do these partnerships help facilitate or prepare students to work with your company?
Well, our experience has been more working with the students at the intern level. Oftentimes, because MCCI is a relatively small company, oftentimes we find that after we've prepared students, they go off places like Google or Apple or something like that, which as a early step in a career, it's certainly financially indicated. And it's also good to get experience in big companies as part of your career. So, but we're fine with that because it means that we've succeeded. We find when we've worked with universities, we've done it in two ways. In the USB business, everything we're doing is closed source, and so intellectual property ownership is very, very important. So we find that it's a lot easier if we just hire the grad students part-time and have them work on projects, and that becomes that then it becomes clear that who owns what, and they get a lot of good experience. They get to work with our engineers and get trained in our practices, and we get influenced by them as well, because they bring in from the academic world the views of how things are done. In the IoT space, MCCI is doing everything open source. We're doing hardware, software, systems, everything is open source. So it's much easier for us to collaborate at the internship level in the classic internship level. We got an intern from Queens College who came in the summer of 2017, and he did our very first LoRaWAN implementation and using hardware from Adafruit, and brought the stuff up, and then of course he went on to he went on to Google. But that was just great because we gave him good experience. He helped us see what needed to be done. He also since MCCI being an older company, there's a generational thing, and sometimes getting the younger engineers in really helps shake things up a little bit. And so that was a great thing. So with working with students who come for the USB business, we basically have found that we have to take students from university and train them. We find that generally speaking, it's so specialized. We can't expect people to come from university with any relevant experience at all, except the groundings in computer science and electrical engineering, and that's okay. If it were really a very popular subject, it wouldn't be such a good outsourcing business opportunity. So with IoT, everything's new, and so we have it. The training is there's of course training that goes on in terms of how to do engineering and how the proven ways that you solve problems, but there's also a lot of opportunity for students to go plow new ground, because the very low cost remote sensing stuff is revolutionary in terms of what you can do. I've been doing industrial controls since the 70s, and back then what was really hard to do is now trivial, both in terms of making the measurement and in terms of the communications. And so now you can go up to the subject matter expert suddenly can be focusing on the very big picture. But there's many details to make it work. And so there's lots of really good projects for the young engineers to work on.
Cool. Well, thanks, Terry. How about you, Dan? I know it sounds like you've had a number of projects with CEIS, and there's likely graduate students involved in that. Can you talk about the value of having those relationships in terms of potential employees or preparing students for the workforce?
Yes, I think it's been very successful, and it's been good for the students. We really do work very collaboratively with them. And for instance, in the terahertz project that Mark and I had mentioned, we developed both the chips, which were mostly done over at the University of Rochester, but then all of the electronic camera system was designed collaboratively, and we did board developments and layouts at Harris, collaboratively with the students. So they got a real sense, of what it's like to work in industry. I think it's very valuable for them, and valuable for us. We got to leverage, their expertise and obviously, the resources at the universities and so I think overall it's been a very good experience for us. And like I said, we've gotten 4 or 5 outstanding graduate students who wound up working for us, in image science and electronics. So I've been very pleased with it.
Cool. Well, I've got a relevant question for this topic. So I guess I'll ask it now rather than waiting to the end. But where is the future opportunity in IoT for students looking to go to graduate school in a particular focus area? So maybe Rein and Mark, Rochester or CUNY, maybe good options, but I don't know. Can either of you guys speak to that?
Well, I could say a little bit. IoT is such an interdisciplinary area that I think there's a great opportunity to or having students work in that area really is an opportunity for them to really integrate their knowledge from a number of different areas. For example, bringing together students from electrical engineering and computer science and working together, or having students who are solving problems in both domains is essential for that area. And it goes all the way back to one of the big challenges is always power consumption. And so we're creating an Internet of Things in a world full of batteries. And so shrinking the power requirements to the point where, or scavenging energy from the environment when that's possible. I mean, that's one area that is, I think there's a lot of activity, and there's a lot of opportunity for, any innovation in that area is going to find lots of application. And so, and approaching things like that is from the sort of project perspective, it's always a very integrated effort. Everything from writing efficient software, writing highly efficient algorithms, and creating the hardware that's energy efficient, and then figuring out, looking at the systems from the user's point of view, and figuring out, what is the useful information, and how much information do people really need, and what quality of information. And so this goes all the way into sort of data science areas, where you're trying to make inferences and give users actionable information, and not overwhelm them with lots of useless information. And so I think that taking an integrated look at what the user requirements are in this area, and how to meet those, coming at it from lots of different areas, I think is a great area for growth. And also, getting back to the previous subject, it's a wonderful training ground for students, because often, the students' education in universities can be very siloed. You take a course on circuit design, and then you take a course on software, but bringing it all together in a project that has a customer at the end who has a need, and sometimes the customer doesn't exactly know what they need, and so helping to figure out what that is and then how to meet it is really invaluable experience for students. And I think the kind of thing that transfers very readily into industry.
Great, thanks, Mark. How about Rein? Opportunities in IoT for graduate students, or rather, what should a graduate student be studying if they wanted to get into the IoT space?
I really agree with everything that Mark just said. I think it's a little bit of rethinking graduate curricula is needed. I mean, I guess traditionally a lot of graduate programs have been set up assuming that students want to be academics, and the reality is that 9 out of 10 end up working elsewhere in small companies or in industry, and we are working very hard to rebalance a little bit. And so that's one aspect. And the other aspect is indeed that this is a very complicated field. It's not, IoT is not electrical engineers, computer scientists. There's a lot more to it. It's social science. It's different types of engineering. All the big data challenges. Spoke with Terry just yesterday about the types of students he would be interested in. It's not just one type. And the challenges are, jack of all trades, or, getting people firmly educated in one area, but still have a good appreciation for how it connects with areas. So working with industry and having industry around the table when you think about rethinking graduate curricula is going to be very important there. In terms of the future opportunity, I think the question, I read it slightly different or also in what is the next big thing. So with connecting everything together, and Mark already mentioned the consumption, there is going to be potentially enormous additional environmental impact. So you build these IoT. Some of it is to measure, try to understand it better, but you also create an additional burden. So, and this is far in the future, but eventually all these sensors will have to be degradable and have to be sustainable. The power consumption needs to be as low as it can be, self-powered, etc. So I think that's getting Internet of Things with also the bigger challenge of keeping the world as a whole sustainable will be a very interesting area for development.
Cool. Well, thanks. I also wanted to actually kick it over to Terry. You're doing some interesting stuff with the Things Network.
Mm-hmm.
Can you talk a little bit more about what you're doing there?
Sure, I'd be happy to. It's a labor of love. We're trying to deploy some of the new technologies that have become available in the last 5 years in a way to enable the use of this technology by people who otherwise would not be economically or technically able to access or make use of that technology. So one of our big projects is starting out now. It's with grant houses on 125th Street in Manhattan, which is the NYCHA project. We were interested in finding out what the tenants wanted to know. And so our process was we got in touch with the tenant association and said, so what do you want to know about your environment? And they said, we want to know about our air quality. So we put together air quality sensors and got the first prototypes out to them and started getting data just at the start of the pandemic, of course. So the project is sort of it's been hard to go around and work on the sensors in the last few months, but that's the kind of thing that we were able to do for just a few $1,000 of out-of-pocket expense. So we were able to get that funded through a little bit of local funding, through the nonprofit. And we're able to get data that they want. So the subjects of the research are also the people who are guiding the research. And that's a totally different thing for the people who are involved with the study. They're no longer research animals. They're research participants. And the data is not owned by anybody else. The data is owned by the study members. So this is something that I feel very strongly about, which is that with having been involved with the technology industry for a long time and knowing a lot about telecoms, and having been involved with various things in the cell phone industry and so forth, the cellular technology is great, but it's very, very, very capital intensive. It's very expensive to develop those chips. They've got lots of transistors. There are millions of lines of code. It's expensive, and that means that using the technology ends up having to have a fairly strong business model. Now, for cell phones, you've got, my joke is always with cell phones, you've got cat videos and ad clicks, and that's what keeps it going. That's what keeps the cell phone companies investing billions of dollars a month in the networks. With IoT, that's not a great technology to deploy if what you want to do is enable local businesses and local small enterprises of one sort or another, researchers, to take advantage of it, because it's going to be expensive, it's going to be complicated, and the networks are going to be biased towards the big revenue sources. And what that does is your business model becomes tricky, and you're going to end up with something where people are using your effort to get the data that they want to have, and that's how you fund it. I would prefer to see, I think for society and for business, in both ways, it's better to have technologies that are suitable for the third of the economy, that is the small to medium size enterprise that still has to compete with the big companies is going to have to use all this IoT remote sensing because it's going to be required to be competitive in the future. They're going to have to depend on local tradespeople, the people right now who come in and do your HVAC, who do all of the stuff to keep your buildings going. In 20 years, they're going to be keeping all the sensors in your building going. We've got to create the teams of people who know how to do that. It's certainly it's certainly something that is totally imaginable and can be done in the context of our current political and social organizations, if I may, but we have to get there somehow. And so that's what the Things Network is all about fundamentally in terms of why we're doing it. What we're doing is deploying this technology and helping people to use it. We've helped a group of students in Jersey City who used the technology and won the Lexus, national prize from Lexus, got $25,000 for the school. These are all middle school young women, you know, and that was very satisfying. We are working with New Orleans. We've got a dozen or so sensors deployed in urban heat islands in New Orleans, tracking local urban heat island issues. We're working with researchers at Washington University in St. Louis, monitoring the activity of research animals in cages. And that is something that they're doing open source, which eventually can greatly reduce the cost of using animals in research and can improve the way the animals are treated, as well as making the dollar stretch further. So there's a lot of impact. From MCCI's point of view, why are we doing it? It's not totally altruism, right? It's all open source. So we get a portfolio that shows what we can do. And our students, of course, get part of that portfolio too. They can, their work is there on GitHub and whatever. And then when the hope for MCCI is that when our enterprise customers, like our traditional business, get ready for using IoT, we'll be ready in terms of our skill set and in terms of our portfolio to engage with them and do the things they do.
Thanks, Terry. So we're coming up. We've got a couple minutes left, but wanted to answer a couple more of the questions that came up in the Q&A chat. When thinking about diversity in the workplace, can you guys share your thoughts on where either your centers are with respect to diversity, and then maybe the companies as well? I guess we can start with Dan.
In terms of diversity, that's a very important corporate initiative, and there's in fact, I think a newly named director whose job it is to make sure that we really maintain a very open and diverse workforce. So that's certainly, a very important thing, corporate culture-wise at L3 Harris.
I could add to that a little bit, Colby. At the university level, of course, there's lots of efforts to have a more diverse student body. But these efforts really have to go way earlier than at the university level. For example, in engineering, the number of women in engineering has historically always been rather low. And, we do everything in our power to give opportunities to women and everybody. But getting people turned on to these career paths early in middle school and even sooner is really critical. And so I think that outreach activities and some of the things that CEIS has done, like we started this thing called Light and Sound Interactive a couple of years ago. It's a big sort of conference celebrating everything to do with technologies that involve light and sound, and getting people excited about these technologies, and And they get excited by the applications of these technologies. And so, movies and music and, the arts and those things, that's what Light and Sound Interactive is all about, is the interaction of technology with, the applications that everyone loves. And getting people excited about those kinds of things at the earliest possible age, and doing outreach to middle schools and even elementary schools. I've gone to elementary schools and talked to fourth graders, and it's a blast to do. But I think that's really what has to be done, I think, and it's going to be it's a long haul. We can't just solve it it's already too late at the college level, and certainly recruiting at the industry level. They can only recruit who graduates from the colleges. And so it's getting the pathways opened up much earlier on, I think, is really the important thing to do. And I think that we can all contribute to that.
Great.
I just want to speak up. I think that, diversity at the gender level is like our biggest problem. Yeah, it's just a huge problem. In engineering, we're doing okay. Engineering is a global industry, and you find in engineering globally that it's pretty diverse. In terms of most of the metrics, but in a gender basis, it's not. It's really something that we have to work on a lot.
If I can just add a couple of short points. So we are actually doing, something that Terry talked about earlier, we have started what we call a citizen science lab, where we get high schoolers from the local area to basically play with and put them together themselves to learn how this works, and indeed get them in early. CUNY is well known actually for bringing students from the bottom socioeconomic quartile into the top socioeconomic quartile, by far #1 in the country in that area. But it's not so strong in doing this in STEM. So we are especially focusing on this now. Colleges have 90% minority student population, even in STEM. So it's incredible. And it is up to make sure that they learn about the application areas and get involved early. So it is very high up on our agenda to help try to do something about this. And again, working with industry is going to be very, very useful there. I think when students learn about you get anything and start a company, that kind of thing is very exciting, and many of them don't know about this.
Great, thanks. There's one more question, but we're coming up on a close. It's an anonymous viewer, so I hope that person can reach out after, and maybe we can get an answer. But I just wanted to wrap things up and thank everyone for joining. But before we go, if anyone had any final thoughts on the panel that they wanted to share with the audience, feel free to give those thoughts. We'll start with Terry. Any closing words?
Well, I think, I guess the thing for me for IoT is just, if to follow up on a lot of this stuff, one of the things that's really attractive for IoT for changing engineering is because it requires generalist skills. One of the, and this is a challenge when working with traditional academic training, because academic training, as you go up the pyramid, you more and more concentrate. And what you need to do to really go after IoT, at least right now, is you have to have knowledge of business. You have to have knowledge of economics. You have to have knowledge of human behavior and insight into privacy issues and all of these things that cover the space from philosophy to transistors. It's a big space. So this may be an opportunity that we should pursue to bring in different kinds of people in different ways, different people with different backgrounds and people who maybe didn't come up through the normal STEM chain in high school and middle school, and get them involved in technology.
Great, thanks, Terry. Sorry, my dog has a question as well, but Dan, he's not going to give an answer. Dan, any thoughts on you for closing up?
Just really just following up with what I said previously. I think it's been very successful. We certainly plan to continue doing this joint collaborative research programs with CEIS and the University of Rochester and RIT. In particular, you know, our programs are more aerospace centric, and a lot of the engineering is more smaller improvements, but you know, it's been very good to work with the students there, and it's also been I think mutually beneficial. And as I said, being able to both work with them on our programs and advanced technology, and then have them have the opportunity to come and work with us after graduation.
Great, thanks. And I probably got a little overambitious with that final question there. So I have a hard stop at 10:50, and I'm already over. But I wanted to thank you everyone for tuning in, and thanks to the panel for your time. This will be recorded, and you can find the recording on the FuseHub website after everything gets wrapped up. So thank you everyone, and have a great rest of the day.
Thank you.
Thank you.
Colby.
Bye. Bye.